Welcome everyone to the 27th episode of the project AstroMiner, or the space shooter DevVenture. So we finished off last time where I had defined the architecture for this next phase of the enemy AI, right? And while my focus isn't completely going to be devoted to making the AI right now, I'm not going to be focused on the AI completely for the next, foreseeable future. my primary objective right now, my focus is to lay the foundations for the testing environment. To lay the foundations for the testing environment of the AI, right? So that when I start implementing these behaviors and strategy and tactics patterns, then I at least have a testing environment for them that I can compare previous progress with current progress, and obviously measure my progress and how things are moving along. And this is my way of doing things. I've always, no, well, maybe not always, but I definitely follow that paradigm of making they call it test-driven development, but this isn't necessarily test-driven development in the strictest definitions, although it is a type of test-driven development. Okay, so I'm building a testing environment where I can validate my mechanics, or that things are working, and prove that at least during runtime that things are working the way they should be. Whereas with test-driven development, you are writing things like a unit test to make sure in the logic of the code itself that things are working. And I never really ended up doing that, so I can't advocate for it or against it if I haven't actually done it. You know what I mean? So I would recommend investigating that for yourself and seeing for yourself if you if you find it useful or not. But I can't tell you to do it or don't do it. I can only tell you that from my experience, it definitely helps to have a testing environment first, right? Where you know for a fact that you are going to need to watch these. So in my example, in my experience in this project so far, I know for a fact that I need to be able to see the enemy ship flying around, and I can't do that necessarily from the player's ship. So from within the player's controller and the ship, and flying around from a first-person perspective, that's not necessarily agile enough or fast enough, or has a wide enough perspective and field of view for me to see effectively that the enemy AI is behaving correctly. And so I created that scene called testing seek behavior, and I developed the orbit camera, right? So let me just show you what I mean by the orbit camera. So if I go to testing seek behavior, there's this camera that I developed here called orbit camera. Okay, so if I run the scene, you'll see here, like, ignore everything else, just focus on how the camera is behaving. Okay, just give it a second to start running. So you can see now that I'm able to orbit around the scene, right? So left and right moves it in that way, and then up and down moves it in that way. And I can do diagonals if I wanted to. It's just the camera is always looking at this focal point at the center, and I can zoom in and out as well, right? So I can zoom in until a specific point, and I can zoom out until a specific point, and I clamped that so that I don't go too far out or too far in. And I've added those waypoint number labels and enemy number labels just so that we can keep track of when I press a waypoint button, right? So if I press, for example, numpad 4, then I can make sure that the enemy is moving towards that exact that waypoint and not another waypoint. And then I also don't get confused, right? I'm like, oh, which one was waypoint 4? You know, like that kind of confusion. So it avoids all of that. So now you can see that I've created these, you know, I've created a testing environment just for, just excuse me 1 second. Someone's trying to call me on WhatsApp, and I don't think it's important, so I'm going to ignore it. Actually, no, just give me 1 second. Hello? I can't actually talk right now. Can I do this call at after 3 o'clock? Okay, thank you so much. Okay, bye. I'm so sorry about that. Thank you for your patience. I had to just postpone that call for later. Okay. Is my camera not working? See, my phone is my camera, so that's why it wasn't working when I took that call. And I suppose that's a good thing, because otherwise you'd be seeing disorienting camera feeds. Okay, you know what? I'm just going to disable my camera because it's clearly making problems. So we'll just do without my camera for now, okay? And so now, okay, where was I? I was talking about having a test environment. Yes, the importance of having test environments. So one of the first things I said when I started doing these live streams was having a testing environment is extremely important, right? And so you can see that I've got these three, what do you call them? Scenes. Sorry, I'm just a little bit disoriented from the disturbance that I just had. The phone call that wasn't supposed to come through now. Anyway, here's the firing range, and I'm sure you've seen this one before, right? This scene was designed as the testing environment for shooting, right? Hurting targets or damaging targets and testing the health and damage system, and also shooting and making sure that projectiles are fired and that they collide with things and that they damage things. And then it also tests the health and damage system so that things can get damaged, that the health bar reacts, and that the object is defeated, in quotes, defeated, right? Either destroyed or incapacitated or whatever, right? And then later on, you saw how I advanced this testing scene into testing the mining equipment as well, right? So you could test a mining object and a firing target. And then there's this scene, the testing scene for flight, right? So you can make sure that the flying behavior, the camera controls, the first-person controls, the flight controls, all of these things are working properly for the player controller. So that's what I'm trying to do here. I'm trying to advance the testing seek behavior scene to be more than just testing seek behavior, right? I'm trying to make it so that I'm trying to make it so that I can test all behaviors, not just seek. And later on, I'll be able to test strategic patterns, with multiple enemies doing all kinds of maneuvers and behaviors in the environment. Multiple enemies going for multiple waypoints and doing all kinds of complex behaviors. But to do that, I need to have a foundation, right? And that's my point. The whole point was trying to get that foundation established. So I'm sorry about the phone call that came through, and thank you so much for bearing with me through that. Let's continue. So I was here on DeepSeek, and I had written my prompt at the end of our live stream yesterday, or in the last live stream if you're watching this asynchronously. Then we were gonna go through the output, but we had run out of time. So let's do that now, okay? So to recap, I have a 3-layer architecture, or a 3-player architecture. As I said, there were 3 players in this architecture, right? And it's not necessarily layered, although it is actually layered. No, never mind. I stand corrected. It is actually layered. So let me show you what I mean by layered, because it's not necessarily clear. Okay, so I'm going to draw some explanations down here, then you can see what I'm talking about when I say layers. Okay, so in computer science, there are these things called design patterns. Okay, and one of those design patterns is the layered architecture. It's an architecture pattern of a system as a whole, right? Or a subsystem. It doesn't have to be the full system. It can be a subsystem. But the point is that there are layers. All right. So let's draw that layer thing. I'm not going to take up this whole page because, like I've shown you in the past, I like to keep my canvas for multiple live streams and for multiple purposes than just one explanation. So I'm going to divide this into just a small quadrant, or not even a quadrant, just a subsection. Because quadrant has a very specific definition, as in divided into 4, whereas this is not necessarily divided into 4. It's just a rectangle subspace. Okay. Colors, I'll go with blue-ish. Okay, let's do that. So we've got these lines. Oh, I've already finished the line. Let me just use my mouse for this because my pen is not reliable for drawing lines. It always releases too early. And I can confirm the line before I release. So just excuse the lines not, in the not so perfectly parallel nature. The whole objective of this is to be a sketch not a diagram, so it doesn't have to be perfect. Anyway, we've got these layers, okay? And so these layers have names. I'll just switch back to layer into white instead of blue so that we can have labels. So this is layer 1 and this is the highest layer, okay? And this one will be the enemy ship controller. So this is just a little notification to you all who are following. That call I received is quite important, but I had tried to organize it to happen outside of the live stream. And so now it's currently 20 past 2 in my local time at the time of this recording. And I've scheduled that call now for after 3, and I'm not sure exactly when after 3. So just to be safe, I'm going to have to close this live stream just before 3, which means that we're going to be just under an hour today. So thank you for your understanding about that, and just letting you know so that there aren't any like surprises at the end. Okay, so this is the enemy ship controller, and this one here is the NPC behavior manager. Remember from last time we talked about these entities or components. I'm writing component when I'm supposed to be writing behavior because I'm talking about components. Enemy behavior, NPC behavior manager. And then this one at the seriously, this one at the very bottom is the specific behavior. So we'll call it behavior underscore type T. Okay, and this type T thing is I borrowed it from C++. It's basically from the template notation. Okay, and so there's this behavior template that we want to establish, not necessarily a template, but yeah, it could be a template. We could even make it a resource, you know. We could make it a resource, but I would rather not make it a resource. And I'm just writing it out as a like in template notation because it could be any behavior. It could be behavior seek or flee or pursue or follow or queue or chase or shoot or mine or scan or whatever. It doesn't have to be a specific behavior. But the point is, all behaviors, every single kind of behavior that you can think of that I listed and the ones I didn't list would fall under this particular layer here at the bottom here, right? And so you've got the enemy ship controller, the NPC behavior manager, and the behavior, whatever it might be. And they are communicating with each other on an adjacent basis. And this is the perfect example then of what a layered architecture is like. And another example of, or one of the principal examples of a layered architecture is the internet. The internet is a layered architecture in terms of its infrastructure, how it's built, right? And I'm not going to go into that now, but you can look it up. You can say layered architecture of the internet, and you'll find diagrams about all the different layers, from the hardware layer all the way up to the highest level layers, which is what you are interacting with on a daily basis. So, it's called the physical layer at the bottom, right? So cables and routers and all of those things at the bottom, and it builds up to the top. Okay, that's enough. I said I wouldn't talk about this. Now, the enemy ship controller interacts with the NPC behavior manager of every single enemy ship, right? And we're not concerned with that right now. We're just talking about the layers. Okay, so let's switch over to yellow for signals. Okay, and so it communicates with this one like this and says, let's just zoom in so it's easier for me to write. It says follow a pattern. So it'll be pattern, and I'll use the template notation again, just so that it's as general as possible. Pattern T. Okay. So the enemy ship controller says follow pattern T. Okay. And then the NPC behavior manager will instruct a particular behavior to do a certain thing. Okay. So the enemy ship controller is not concerned. It doesn't care what the NPC behavior manager does with this information. Right? It has this trust that the NPC behavior manager knows what to do when I tell it. So if I was the enemy ship controller, I don't care what NPC behavior manager does with my informing it that it needs to start following pattern T. Okay. When I say follow pattern T, then I'm trusting the NPC behavior manager to know what to do with that information. I don't care how it handles it, just that it handles it. Okay. And so the NPC behavior manager in this diagram, we don't care how it handles things because we are looking at things from a layer perspective. What is going on? I've got another phone call. That time it was a spam call. I need to figure out a way to block calls when I'm doing my recordings. I'm so sorry about this. Thank you for bearing with me. Okay, so let's save this diagram because I need to the 10th. We're talking about the 23rd of the 10th. Notes on the 23rd of the 10th. Okay. Now where's my drawing tablet? So as I was saying, the enemy ship controller informs the NPC behavior manager that it needs to follow pattern T. And then based on which enemy the NPC behavior manager is attached to, it will call a specific behavior. Okay. And so now let me just label the sequence. So the sequence of events is this. Step 1, not on pen mode here. So this is step 1. Okay. And then step 2 is internal. So step 2 is choose a behavior. And then step 3 is inform that behavior. Call behavior underscore T. And then again, the NPC behavior manager is not concerned with how the behavior of type T is executed, just that it executes, right? So think of Star Wars, for example, with Emperor Palpatine when he says, execute Order 66. He doesn't care that the clones, use their blasters or throw grenades or fire cannons or do whatever, as long as they execute order 66, right? And so it's the same thing with a layered architecture. So behavior T then executes its instructions inside its function. So we'll say here for oh, I need to switch to pen mode again. So at step 4, runs its logic. Okay. And then step 5, so this is on the way down. So let's color code it in that way, right? So that we can see very clearly that going on the way down is yellow, and then going way back on the way back up, it's going to be a different color. So let's change the color to a different one, something like magenta or purple. We'll go with like a lavender-ish color. Something like that. Okay, so now we'll just say, what was that one? 4, right? Yes, so this one is 5. So step 5, and that one runs back up like this. And that would be emit signal of task status. Right? And then that might go towards the NPC behavior manager, but it might also go towards oh yeah, it has to do this. It might also go towards the enemy ship controller because it's a signal, right? And the signal could be connected to either of these things. And so now we switch back to pen, and we have done that already. Okay, good. So I think this diagram explains quite clearly how the layered architecture is supposed to work. Please do let me know in the comments, if you don't mind, just let me know in the comments if you are able to follow along with this diagram, if it makes sense to you. If it doesn't, then perhaps I could explain a bit more clearly. But at least to me, I think this does make some sense. I think I've explained it quite clearly, but confirmation would help. So if you are able to write in the chat, then please do that. I'll continue in the meantime. Okay, so yeah, we'll go through the response from DeepSeek, and then we'll start planning how to write things in the GDScript code. Okay, so here we've gone through my prompt already, but let's just go through it again. Okay, so I said, okay, then we can go into the details about my idea, because I remember I checked if we could have nested match statements. And so now that we know that we can, this strategy and tactic system is meant to create a dynamic and diverse set of behavior patterns for my enemy ships. And remember, enemy ships could be of any type. It could be of the defender, the miner, or the pirate. It doesn't matter. And then this will create a more engaging experience for players and prevent the game from becoming a so-called solved problem. Players will not be able to learn the enemy ship's behaviors easily, thereby getting bored with the game. There are 3 key players or layers in this architecture. The enemy ship controller singleton manages all the enemy ships in the scene. It is responsible for the strategy and directs the enemy ships to follow behavior patterns. It uses signals to communicate with the enemy ships and receives signals from enemy ships to keep track of their progress, because monitoring positions and states every update is unnecessary computation. It is not concerned with the specific behaviors employed by each enemy ship. It only cares that the overall objective is completed. Alright, and then the next one is the NPC manager. So the NPC manager is a component of the enemy ships, and it receives the signals from the enemy ship controller singleton. It is not responsible for understanding why a particular pattern was chosen. It only cares about how it can fulfill its responsibilities towards the chosen pattern. It decides which behavior to invoke from the collection of behaviors attached to it as child nodes. 3. The behavior of type T. The behavior node is a specific operation that manages the steering, movement, attacking, or any other behavior of the enemy ship. It is invoked by the NPC behavior manager, and it emits a signal with its enemy ship ID and the status of the behavior once the operation is completed. For example, in behavior seek, the signal emitted would include the ID of the ship, the target it reached or didn't, and the status of the task, i.e. target reached, interrupted, destroyed, etc. The signal would vary depending on the behavior chosen. This is probably more, there's probably more I need to tell you about this, but this is all I can think of right now. Okay, and so this is the response that DeepSeek gave me. This is a really well thought out architecture. The separation of concerns is excellent. Your 3-layer architecture, one enemy ship controller, the strategic layer. Its role is grand strategy and objective management. The focus, what needs to be accomplished. The communication, it uses signals to the NPC behavior manager. And the data, overall mission state, and enemy ship assignments. Alright, then the NPC behavior manager, which is the tactical layer, has the role of pattern execution and behavior coordination, a focus on how to accomplish the assigned pattern. It communicates with invoking specific behavior nodes, and the data it manages are current behavior patterns and the ship state. And then behavior nodes, the operational layer. Its role is a specific action implementation. The focus is on executing this specific behavior. The communication is that status signals back up the chain. It sends signals back up the chain, and the data it manages are behavior-specific parameters and the state, right? And then this naturally fits nested match statements. So here's an example. Match a mission objective, so in the enemy ship controller, with the strategic decisions, right? So matching an enemy a mission objective. So if the mission objective is to defend the base, then check the threat level, right? So this is another match statement. So if the threat level is low, then assign control pattern for patrolling. And if it is high, a high threat level, then assign the swarm pattern. And so if the mission objective is going from defend to attack, then check the player's health. If the player's health is still high, then assign the harass pattern. Alright, so like slightly different to the next one, which is when he's low, then do the aggressive pattern. Harass versus aggressive could mean anything, right? But in my game, it would mean something like harass could be something like you have multiple enemies swooping in, shooting, and then swooping out again. Whereas aggressive would be like charging at the enemy with like barrages of fire, you know, and not swooping away until the very last second. Whereas harass could be shooting from further away and just like annoying the player, as opposed to really threatening him. So in the NPC behavior manager, we've got the tactical decisions, right? So match an assigned pattern. So if the pattern is patrol, then match the current waypoint status. Okay, so if he's on patrol and he's going towards a specific waypoint, has he reached it? If he's reached it, then select another one. And if he has been interrupted, evaluate the threat or do something else, right? So the key benefits of this is that it's decoupled. So each layer only knows what it needs. It's extensible, which means that it's easy to add new behaviors or patterns. Again, you only need to connect whatever you're building to the immediately adjacent layer, or the layer that is concerned with it, right? So if I'm adding another behavior, I'm only concerned with connecting that behavior to the NPC behavior manager, right? So ideally, we don't want this arrow. We only want this arrow, because then it's modular, right? So any behavior of type T can connect straight onto the NPC behavior manager, and you only need to work with these two. Well, I mean, in theory, you would still have to connect it to the enemy ship controller, because the NPC behavior manager has to send feedback up the chain towards the enemy ship controller once this pattern is executed, you know? So this diagram isn't necessarily complete. There are a few more steps, but the point is that it goes up and down the chain by layers, right? So enemy ship controller communicates with this one, the NPC behavior manager connects with this one, and the behavior of type T communicates back to this one, which then communicates back to that one, okay? And then maintainable changes in one layer does not, the changes in one layer do not break other layers. And it is performant. So there's not a per frame monitoring overhead. Like I said before, every single frame in the update or the physics process or whatever you want to call it, if you use that here, physics process, or the process, right? So process is called every single frame. Okay, that's why it's got this variable called delta. And if you were to manage from the enemy ship controller every single frame in the process, you know, who is where and what are they doing and why, and you know, what is the health of each enemy, and what is the position of each enemy, and what is the ammo status of each enemy, and what is the you know, the cargo, if any, if they have a cargo hold, what is the, you know, capacity filled of that cargo hold of each enemy every single frame. You can see how that adds up really quickly, right? Especially if you're doing 60 calls a minute. I mean, a second, not even a minute. If you're doing 60 frames a second, and every single frame you're doing that many checks, you can see how that kind of adds up really fast and starts taxing the player's machine with all of these computations, which are unnecessary. You don't need to keep track of all of that at all times, right? So that's what I mean by performant. There are no per frame monitoring overheads. This is a professional grade AI architecture that will definitely prevent the so-called solved gameplay. What specific behavior patterns are you thinking of implementing first? Okay. So now that we are caught up and everybody is hopefully on the same page with me, let's get started with planning the next step. Specific behavior patterns are you thinking of implementing first? Okay, so let's write this prompt out, and then I think we'll probably run out of time, because again, like I said, I do have a call that I need to take, and I do need to prepare for it. So, you know, I will need to cut this call, the live stream a bit shorter than usual. Anyway, that's my problem, not yours. So let's write this prompt. I want to use ordinary nodes for the NPC behavior manager, and all behavior underscore type T nodes, where T represents the specific behavior name. let's get started on the foundation of the NPC behavior manager script and class, please. We can begin by thinking about its adjacent layers and how it must interact with them. Okay, so here's what it said. Excellent. Let's design the foundation for the NPC behavior manager. Here's a solid starting point. NPC behavior manager.gd extends node, class name NPC behavior manager, and then it's got this onReady variable called enemy ship of type enemy ship, and then the reference to the enemy ship that this manager controls, right? And then current active behavior pattern assigned by enemy ship controller. It's got a variable called the current pattern of type string, initialized to be an empty string, all right? And then it's got a current active behavior node. The variable current behavior of type node is assigned a null, right? It's assigned null from the start, and we then assign it a node at runtime whenever it needs to. All right, so we're going to have a lot of null checks in our script. This already is a foreshadowing of that. Okay, and so is this. We're going to have a lot of empty string checks as well. So if the string is not empty and if the node is not null, then do the expected behaviors. And so available behavior node available behavior nodes, that's the children of this manager. So variable available behaviors is the type dictionary, and it's also assigned as an empty dictionary. Then we've got some signals. Okay, so behavior is complete, behavior has failed, or it's ready for a new pattern. So these are all communications with the enemy ship controller. We're going to have to connect these to the enemy ship controller at some point. And so the behavior is completed, and then it sends information like which enemy completed its behavior. What was the behavior type, and what is the status of that behavior? Actually, these signal names here are a bit ambiguous. It shouldn't be saying behavior complete. It should be saying pattern complete. Because the NPC manager is not concerned with the behaviors that it calls, right? It should have a function in its class to manage a signal from a specific behavior saying that the behavior is complete. So this is a bit of a mistake that DeepSeek has made here, and I'm going to have to correct it. So let's do that before we move on. The signals you used here are incorrect by my understanding. The NPC behavior manager is not concerned with how behaviors are executed and it does not announce the completion of those behaviors either. The signals you should be defining are for the pattern and this enemy ship's role in that pattern. Okay, so that's the first concern I have with what it's generated. And then in the ready function, it sets up the enemy ship as getting the parent as type enemy ship. And if there is no parent, so if the enemy ship that it's trying to get is null, then push an error in an NPC behavior manager must be a child of an enemy ship. Okay, that makes sense. Then return. And then it's got a function for discover behaviors. This will discover and initialize all behavior nodes. And then connect to enemy ship controller signals. Enemy ship controller.pattern assigned.connect. On pattern assigned, enemy ship controller.pattern cancelled.connect on pattern cancelled. So it's got these functions: on pattern assigned, on pattern cancelled, execute pattern, and these are signals in the enemy ship controller that we are going to have to define later. So in the enemy ship controller, we're going to have to create those signals because we're trying to connect them to these functions. Okay, that makes sense. Then in the function called discover behaviors, which we call here, we are trying to go through all the children of this NPC behavior controller or behavior manager, and you know, like it says here, discover and initialize all behavior nodes. So for child in get children, if the child dot get script, so if the child has a script and the text behavior is in that script's name, right? So get script dot resource path dot get file. So if it contains behavior underscore, then do this thing. But we can actually change this. What if we checked if the children, so let's be more specific. In the underscore discover underscore behaviors function, why not use a behaviors underscore type T group to check if the node, the child node, is a behavior node. This will be more robust against nomenclature changes for the project's lifespan. So that's my second concern, is instead of checking for the script's name containing behavior underscore, why not just use a group where we have a group tag for the behaviors nodes saying behaviors of type T, right? And then so we'll just ignore this and say, okay, well, if this child has a script and it has and it is in the group behaviors T, the same body will apply, right? Then behavior type is child name dot replace behavior underscore with empty string. dot to lower. Available behaviors, behavior type child. If child.has signal behavior completed, then the child.behavior completed .connect on behavior completed. So if the child has a signal for behavior completed, then connect that behavior completed signal to our on behavior completed function somewhere here below, right? This one. And then function on pattern assigned, take in the enemy ship ID, the pattern string, and the parameters dictionary. Parameters is of type dictionary, and the pattern is a string, the enemy ship ID is an integer. So if the enemy ship ID is the same as the current enemy ship's ID, then execute pattern, the pattern string with the parameters in the dictionary. And then the execute pattern function is defined down here, so we'll get there. On pattern cancelled, enemy ship ID int. So if enemy ship ID is, so if this is the right enemy ship basically, so if the parameter passed in matches with the enemy ship's ID, then call the cancel behavior function, which is defined down here. And you can see this carries on for quite a while. So I really do have to close this live stream at this time, you know, because it's almost 3 o'clock at the you know, in my local time, and I do still have that call that I need to manage. So thank you so much to those of you who have joined me for this live stream, and to those who are watching after the time of recording, thank you as well for your time and for your attention, and for bearing with me through these moments of turbulence. And then again, a big shout out to our junior DevVenture Cubes. Thank you so much for your support. It means a lot. And I think that's it. I will see you all in the next live stream.